What I really liked about RatedPower is its development from a few years ago when we first talked at Intersolar, and the rapid growth of the company and the capabilities of the tool. So you would have updates regularly, which really have a real update and a real impact on our work. And at the same time, you have a much more detailed design. So now we're moving from preliminary to basic design capabilities in a tool. Hello, my name is Philip Manz. I'm the pre-construction manager for Engie Renewables Germany. We are part of the big Engie group, which globally is one of the market leaders in renewable energy production. And in our department, we are a few dozen energy enthusiasts who work to make the German Energiewende happen every day. And therefore, we're driving forward to have an integrated assessment of renewable energy assets all over Germany, and which is why we're now using RatedPower tool for our solar assets. Our target model is an integrated optimization approach. And therefore, we were looking at all the different options a few years ago, which could fit in best in our approach towards that. One of a few targets we wanted to meet was reduce our workload and early stage assessments of projects while keeping profound engineering capabilities in-house, and move the project towards final development with certainty on the design. And RatedPower allows us to keep and check all the critical parameters of a project, such as the project site, yield assessments, technical designs, variations such as models, inverters, transformer stations, and adjust those to current market trends. And at the same time, we can also assess risks we see in the project, such as changing topography or access roads, and improve the layout according to those risks. We cut down engineering time on an individual project with quite high certainty on the layout and yield, probably by 30 to 40%. Furthermore, we also were able to use the results of RatedPower, which and compare them to our results of projects who went to a final development stage and even further, to reassess that into the software and take the learnings from the return of experience we had from those projects into the software, and can now even further analyze results, knowing what we know about projects in later development stage, and increase the certainty of the design we have. So this is a real time value for us, of course, but it also helps because we have limited human resources, meaning that the people we have can now work on more projects while keeping a standard over all projects, and therefore improving our capabilities to assess our pipeline. The features we use the most in PV design is the iteration process we have now in the software. So employ all the different information from the real world into the project and the layout, such as updated weather resources, updated topographies, updated technical logical developments such as modules or inverter structures. We also can use a comparison between different manufacturers due to the cost inclusion of the tool. And in addition to this, we can use the reports generated by PV Design in multiple languages to have an exchange of a project very early stage on a very detailed level with multiple stakeholders such as grid operators, colleagues from other countries, or internally with the development team, the business developers, or the engineering team. So since we have also a lot of projects we look at for project acquisitions, we can look at the design provided to us by a third party and challenge this design internally with quite a lot of variations we can quickly assess, and therefore have a more competitive design later on. But it also helps us, of course, in other situations such as EPC tenders or further in the development phase of the project.